The Model Context Protocol is fast becoming the USB-C of AI agents, a single open standard for connecting a model to external tools, data sources, and actions. An MCP server advertises a set of capabilities, tools it can call, resources it can read, prompts it can run, and any compliant client can connect and invoke them. That interoperability is the whole point and is genuinely useful. The problem is cultural and historical. The protocol grew out of local, single-user setups, where the client and server lived on the same laptop, so authentication was treated as optional. When developers lifted those same servers onto the public internet to share them, the auth optional default came along for the ride. And optional, in a hurry, almost always means absent. This isn't theoretical. Census scanned the public internet and found 12,520 reachable MCP servers, a count that has only climbed since. Roughly 40% of remote MCP servers expose their tool surface with no authentication whatsoever, connect, enumerate the tools, and call them. And the 60% that do gate access aren't automatically safe. A large share lean on long-lived static API keys baked into config, which leak through logs, repos, and screenshots and never rotate. So the realistic picture is worse than 40% open, is 40% with no lock at all, plus a meaningful slice of the rest using a key that's effectively a password taped to the door. Open access is the front door. The vulnerability classes are what's behind it. An automated scan of roughly 40,000 MCP repositories surfaced 106 zero-day vulnerabilities, not misconfigurations but novel exploitable bugs. Around a third of servers are susceptible to server-side request forgery, which lets an attacker use your MCP server as a launch point to reach internal services that were never meant to face the internet. Cloud metadata endpoints, databases, admin panels. And because MCP tools are described in natural language that the model reads, attackers poison those descriptions. A malicious tool definition or a booby-trapped resource becomes a prompt injection vector that hijacks the agent itself. The most serious finding isn't a single buggy server, it's a flaw in the design itself. Security researchers identified a remote code execution class baked into how MCP handles trust between client and server. The protocol's implicit assumption is that the tools you connect to and the data they return are benign, so outputs flow back toward the agent and its host with too little isolation. A hostile or compromised MCP server can exploit that trust to drive execution on the client side. This is why just add auth isn't the whole answer. Even an authenticated connection to a malicious or compromised server inherits a dangerous trust model. You have to assume the other side can be adversarial. Here's the defensible posture. 1. Authenticate every connection and do it with short-lived, narrowly scoped auth tokens instead of static keys, so a leaked credential expires on its own and only ever opened a small door. 2. Never expose an MCP server directly. Put it behind a gateway, VPN, or service mesh with network policy so reachability isn't the same as 12,520 servers on the open web. 3. Enforce least privilege on the tools themselves. Allow list exactly which tools an agent may call, sandbox the execution of tool results, and treat every output as untrusted input that could carry an injection or an RCE payload. Auth fixes the front door, the network boundary and the trust model fix the rooms behind it. Step back and the lesson is simple. An MCP server is production attack surface and you should treat it with the same seriousness as any other internet-facing service that can run code on your behalf. The default assumption should be unauthenticated remote code execution until proven otherwise. Start with an inventory. Most teams that audit honestly discover MCP endpoints they forgot they stood up. The protocol is young and moving fast, which is exactly why the security practices around it have to mature faster than the convenience. Give your agents tools? Absolutely. Just don't hand the keys to the whole internet while you do it.